Hi folks, today we will try to learn HDFS, the basics of HDFS and what role it plays in the Hadoop file system. We would also try to have a practical lab on HDFS where we would try to create commands. We will run commands to create files and do all the other awesome stuff you can do with HDFS. So let's start with the presentation. To begin with, I would like to explain to you what HDFS is. HDFS stands for the Hadoop Distributed File System. What it essentially is the storage component of the Hadoop ecosystem. What do you mean by that? We all know that the Hadoop ecosystem has two major components. One is the storage component where we store the big data that we need to analyze, and the other is the compute uh, component where we run the code which derives insights from that data. So the big data that we all want to analyze using Hadoop is actually stored in HDFS. The key words here I would like to focus on is distributed and file system. So file system is, a software component which helps you to organize files on any system. When I mean organize files, what I mean is you'll be able to create files using it. You'll be able to, organize files into directories, and then it'll provide you interfaces with which you can retrieve files, you can move files, copy files, and so on and so forth. The other keyword here that we want to talk about is the distributed nature. So normally every laptop, every computer that you interact with has a file system in it. But that file system is limited to the hardware capacity of that particular laptop or computer. The Hadoop distributed file system essentially helps you to store files using multiple machines. Hence, it's a distributed file system. The next thing I would like to address is why is HDFS even needed? Why is HDFS needed for us to be able to do big data? The answer to that is pretty simple. Big data has special storage requirements. We will go through those requirements one by one and see what those are. The first requirement of any big data system is that it should support to store a large number of files. Now let's actually think, why would big data lead to large number of files? Let's say you are an e-commerce website that has been running for 4 or 5 years, and you have created a lot of files, let's say log files, or log files of your application server or whatnot. So basically you have a file per day or maybe a file per hour on each server that was running your software. So if you compute, in 5 years you have 365 into 5 days, and in each of those days you have 24 hours, and in each of those hours about 1,000 servers is creating a file. If you multiply all that up, you'll be surprised to see the number of files that you have actually created. Now if you want to run any kind of analytics on all these number of files, then the system which is storing these files needs to be able to support so many files present inside it. Hence, most big data systems have a requirement to store a large number of files. The next requirement is the ability to store large files. When I mean large files, I'm not talking about a megabyte. In fact, I'm not even talking about a gigabyte. I'm talking about, in some cases, the ability to store files that are a terabyte in size. A single file which is a terabyte in size. Now, why would that happen? Why would, big data lead to files, lead us to, analyze files which are as large as a terabyte? Many times what happens is systems are built in place and then big data comes in later. And big data has to work on all the historic data that has been collected so far. For example, in the same e-commerce company that we were talking about, let us say when the big data system has to go live, you get a dump of all the orders placed so far on your website in one file. Each line in that file represents an order placed by a customer on your site. In such a case, we can estimate, let us say, a site which has about a lakh orders in a day, and in 5 years that would have accumulated 1 lakh into 365 into 5 orders. Now, even if we assume each line, each order is represented using 30 characters, then you can estimate the size of that file. That will be a pretty large file. The other big thing about, special thing about big data storage systems is that when you put a lot of data in it and you accumulate a lot of data from different sources and you put that into the distributed file system, that data should not be lost. If the data is lost, there will be a huge implication to get the data back. Maybe using the data, all the insights that you have drawn are also stored in the file system. So if that is lost, you have essentially lost all your insights that you have gained over the many, many years you have done analytics. Hence, the Hadoop file system or any file system layer in a big data technology needs to support the use case where data stored in it should not be lost. Now, coming to the most challenging part of any storage system is that when you want to finally access the large files or the large number of files that you have stored in the file system, it should be fast. It cannot be slow. It cannot take, seconds and minutes to load a large file. It should be able to give you the file as quickly as possible. So moving on, now that we know what are the kinds of expectations that HDFS had to begin with, let's try to learn a few characteristics of the Hadoop distributed file system. The first characteristic, which is essentially in line with the big data, the big data philosophy, is that the amount of files and the number and the size of the files and the entire capacity of the file system in terms of the number of files or the size of the files that you store should be expandable. Today you might have only files worth 1 terabyte, but what if every day you are adding 5 gigabytes of files into the file system? So your file system should be able to grow as time progresses. Hence, it should support expandable storage. Such file systems or such systems which can grow as per demand are also called scalable systems. So essentially, HDFS is a scalable file system because big data accumulates over time. Next, the other characteristic of HDFS is that the data you put into it has copies. If I put a file into HDFS, it will maintain multiple copies of the file. What that ensures is that the data is not lost. That again is in line with the expectations with which we saw in the previous slide. So such systems which keep copies of data so the data is not lost are called replicated systems. And the Hadoop distributed file system or HDFS is a replicated file system where each piece of data you put in it is stored as multiple copies so that even if one copy is lost, the data is not lost. As we saw in the previous slide, Hadoop distributed file system HDFS can store very large files. It can store files which are, a terabyte in size, maybe even more. This is in line with the expectations of big data, where you might get a dump which is, huge, and the file system has to support it. HDFS also supports faster retrieval of files. It does this by having the ability to use multiple machines to serve the file that you are trying to retrieve. And it is also optimized at multiple layers from the code layer to the operating system level to be able to serve each part of the file very, very fast. In fact, HDFS also supports you to stream a file. So let's say you put a video file into HDFS and now your user comes and wants to play the video. As you all know, videos are streamed across the internet. Only a part of the video is required at any point to be played. You don't need the entire video to be loaded for the video to be played. So HDFS also supports stream, in which you can stream the file content from HDFS to your application and then to your end user, who can then play the video by downloading it in an incremental fashion. Let's move on. The last and the most important characteristic of HDFS is once a file is put inside HDFS, it is ready to be analyzed using the MapReduce paradigm. So Hadoop basically provides the MapReduce computational layer, but that layer works only on data present on the Hadoop distributed file system, or HDFS. So the last characteristic of HDFS is if you have data in HDFS, then it is ready to be analyzed using the MapReduce and other techniques of computation, and insights can be derived from it. All right, so now that we have a basic understanding of HDFS, let's go ahead and try to do a little bit of practical HDFS. What I mean by that is, let's try to create a directory in HDFS. Let's learn how to create a directory in HDFS. Then let's learn how to store a file inside that directory. Then let's try to list the directory to see all the files in it. Then let's retrieve a file that we put. And last, let's delete the file so that we have a clean slate, and let's move on.